Hello, my name is Dr. James Wootton. I'm from the University of Basel, and I have made a couple of games for iOS and Android that have some puzzles to solve. But they're not just any puzzles, they're exactly the puzzles that we need to solve in order to do quantum error correction and build a quantum computer. I'm a scientist that works on devising these methods, but you can be a scientist that works on the same thing by playing our apps and finding methods of your own. The purpose of this video and the next few videos in this series are to tell you about methods that we scientists already know about how to do these error correction problems. But they're not very good, and we're sure that you can come up with better ones. So watch these videos, work out what we do, and find out where we've gone wrong and how you can do it better. The first method I'm going to tell you about is called expanding diamonds. It was just 15 years ago by Landau and Dennis and some others, and it was rediscovered by me a few years later. So it's one that I know very well, and so I'm going to take you through it personally. What we do is basically just go through this grid of numbers. We first go through from left to right, and then from top to bottom. We look at all the numbers and we see if they have neighbours. If they do, then we unite the neighbours. So hopefully you've read the tutorial of this game before checking out this video. If you haven't, the whole point is that there are groups of numbers which add up to a multiple of 10, like this 3 and this 7 here, this 3 and this 7 there, this 1 and this 9 over here, and we can combine these in order to get rid of them, and by doing so we can try and work out what is in the question mark blocks. So here we see that we've done this, and there is just this 6 here near this question mark. Now the groups are usually quite small, so there must be a 4 over here, and over here it's a bit more complicated, but in the end we find that there's a 2 there, so that's probably an 8. We can push those in to try and make a multiple of 10 in those blocks, and we then get told exactly what groups everything belonged to, and indeed there was an 8 here and a 4 there, so we were right. So let's do it using the expanding diamonds way. We go from left to right, and then top to bottom. We look at if each number has a neighbour. If they do, we combine them, and then when we finish we are left with a bunch of numbers which don't have neighbours, and we look for next to neighbours and next to neighbours and so on. So we start here. This question mark, does it have a neighbour? Well, yes, it has that one and that one. Let's randomly pick one, this one, and unite it with that. We have to pull the number towards the question mark because question marks don't move. Then we go here. Does this have a neighbour? Yes, it has the question mark. It has this 6. Let's pick one randomly. Let's do the 6. We come along. Does this 3 have a neighbour? The 7 and the 8. Let's pick one randomly. The 7. We got rid of those. That was good. Does this 7 have a neighbour? Yes. This 9. Oh dear, we're doing some mistakes now, but hopefully it won't get too bad. Does this 6 have a neighbour? Yes. This 1. Does this 7 have a neighbour? Yes. This 9. Okay, let's see if we can undo all of the bads that happen there. Does this 8 have a neighbour? Yes. This 2. Then we come along. Does this 6 have a neighbour? Yes. The 1. And this 1 has this 9. This 1 has this 9. This 5 has this 7 and this 5. Let's go for the 5. It's obviously the better choice. Well, it's obvious to me anyway. The 7 and the 9. Let's go for the 4 and the 9. The 3 and the 1. And then that goes there. That, let's go for there. That, let's go for there. And there. And there. And then we have this. And then we have, say, that. This doesn't have any neighbours, so we have to leave it. This 5 does. This 9 does. This 8 does. This 9 does. And this 7 is neighbouring that question mark. So in the end we are left with a 6 and a 1. They don't have any neighbours, so let's now go through and look for next to neighbours, sorry. Does this have anything next to its neighbours? So this is 1 step away, it's a neighbour, but this would be 2 steps away. This also would be 2 steps away. But it doesn't have anything in its next to neighbours either. You might notice that this is 2 steps away, this is 2 steps away, this is 2 steps away. So they form a diamond-like shape. So that's why it's called expanding diamonds, if you want to know. So it doesn't have any next to neighbours. This one doesn't have any next to neighbours either. So we look for next to neighbours. So 1, 2, 3. These are both 3 away from each other, so we can combine them. And this is 3 away from the question mark, so we can combine them, and we can see whether our wonderful method got it right. Oh, it didn't. So, as I say, it can be improved upon. The methods that we have can be improved upon. Let's have another go. Try and make things a little better. So here, when I notice that they'll obviously add up to 10, I'll combine them according to that. So that's a 9 and a 1, 4 and a 6, 2 and an 8, 6 and a 4, 3 and a 6, and then this 6 has this 3 and this 4, but let's not choose randomly, let's go for the one that annihilates. And so on. This 9 with this 1, this 5 with this 5, 2 and an 8, 8 and a 2, 6 and a 4. Bam! We win! So there are examples where we get it right, there are examples where we don't, just in this tutorial video. They're coming up randomly, and we've already got an example of each so far. If we go through, we will find that indeed it sometimes wins and it sometimes loses, as any method will. No method is perfect, no method can do quantum error correction all of the time, but this one does it some of the time, so it's fairly good. But not as good as it could be. I'm sure you can come up with much better methods, both for this and our game Decodoku, which can be solved with similar principles. I look forward to what you come up with. You can do either videos like this on YouTube, you can fill out our Google form, which is just a survey where you get a few examples of particularly hard problems for computers, particularly hard problems for things like expanding diamonds, and you can tell us the way you're thinking about these problems. Or you can do anything. You can also check out our subreddit, which is /r/Decodoku, so that's reddit.com/r/Decodoku. So yeah, become a scientist, help us out, and be one of the people who contributes to the development of quantum computation. Thanks for watching.